All right. Do I just jump into this, or do you normally say something about something?
I think have at it, Brandon.
Oh, okay. All right. Sorry, I've only seen a couple of these. Well, hello, welcome everybody. We're going to talk about sustainability regarding water systems today. Kirk Williams will be presenting. I'm Brandon Martin. I'm the mechanical chief at Louisville District. I'll be introducing Kirk and then monitoring the chat line. So if you want to enter questions as we go along, I'll keep track of those. And Kirk assures me he has plenty of content here to pack into this hour, so we might be a little judicious about the questions that we read off, but if we have time at the end, we'll go through more of those and get through what we can. So without further ado, your presenter is Kirk Williams. He's the chief of the mechanical section at the Fort Worth District. He's been there for 12 years. He's had extensive experience with sustainable design and development, commissioning, lead, energy modeling, life cycle cost analyses. He and I argue every once in a while about life cycle cost analyses, so he's really good at that stuff. He served as his career as a technical authority or subject matter expert and designer on a wide variety of buildings for the Department of Defense as well as other federal agencies. He's designed a number of buildings that have achieved LEED certification. Kirk holds a bachelor's degree in mechanical engineering from Texas Tech University. He's a registered professional engineer, certified energy manager, and a certified building commissioning professional. Kirk was born, raised, and currently resides in Fort Worth, Texas. Kirk, go ahead.
Okay, great. Thank you. So I got y'all on my speakerphone here, so if anytime the audio starts to cut out, just let me know. But we'll jump into it. So excited about this presentation. We're going to be talking on water. So jump into this here. So our objective is summarize the strategies to comply with Army requirements to protect and conserve water. Sounds pretty easy. So resources. This page should look pretty familiar. A lot of the same resources as what we've had with the other sustainability webinars. Probably the one thing that might look a little different on this one is the UFC 210-10, the low impact development. So that would be a little different resource there, and you'll see that kind of come up here as we go through the presentation. So in this presentation, we're going to go ahead and talk through the UFC 12002 section on water, and it's protection and conservation of water. And so kind of a high-level overview of the different topics that we're going to roll through here with this presentation. First one's going to be indoor water, then indoor water metering. Then we'll jump into outdoor water with landscape and metering. And then we'll briefly touch on alternative water and stormwater management. So kind of be helpful, I put some of the criteria references down on this slide for y'all. So that way you can see kind of the cross-reference from the UFC to the kind of nested criteria. So you'll see with a lot of this, we're referencing that IGCC. For those of y'all that remember, that's ASHRAE 189 that's been rebranded to the International Green Construction Code. So that's where that's coming from. And then you see a couple of other things here, the DoD metering policy, you see the cybersecurity, you see the low impact development. So you see a couple other nested criteria in there. So we'll jump into it here. So protection and conservation of water. I really enjoy this. This is protection and conservation of water in action. This is a photo from a restroom door in Hawaii, I'm told. This is what happens when you send interns on trips to Hawaii, is they come back with documentation like this. So enjoy this one. Don't leave the door open, or the mongoose are going to come drink the toilet water. So little bit of comedy to kick this thing off. So the EPA lists that 70% of the Earth's surface is covered by water. Less than 1% of it is available for human use. The average American uses 82 gallons of water each day at home. and bathrooms are the largest user in the home, using more than 50% of the indoor water. And then approximately 5 to 10% of U.S. homes have easy-to-fix leaks that drip away 90 gallons a day or more. The average annual residential outdoor water use for the U.S. accounts for 8 billion gallons of water a day, and that's mainly landscape irrigation. And then, on average, a urinal in a public place gets flushed 18 times a day. So, some kind of random facts there. We can see some of the importance of water. I don't know if any of y'all, I do backpacking, and so I've been on some trips where I've had to carry my own water, and I've also run out of water in the wilderness. And nothing makes you appreciate water more than when you run out. So kind of along that resiliency guideline here of, let's keep the resources, let's not waste them. Protection and conservation of water, it seems pretty common sense. So we'll jump into some of the pieces and parts of it. Hopefully we can get implemented as simple as, not letting animals drink our toilet water. So we're gonna kick this off. We're gonna jump into the first part of the UFC. Here, the first thing that it would talk about is the life cycle cost analysis. So we're not going to do a real deep dive into LCCAs because I don't want to steal too much of my talking points for next week when we do the LCCA module. Just kind of wanted to bring up and kind of go ahead and point out that the water decisions are supposed to be made based on LCCAs similar to the energy. And so I know we'll have some good conversations next week on LCCAs, and then looking forward to that. But boiled down, kind of the one sentence from this slide is the energy and water solutions that are implemented are supposed to be life cycle cost effective. Okay, so next we have the ASA SDD policy. So this is where we have the UFC, and then you also have the SDD policy. So this is the wording from the SDD policy. I'd like to bring that up just so that way people can see, those that live on the Army side, they can see what's going on there. You can see here that the Army added in there about dual plumbing, enable the facility to use both potable and alternative water where life cycle cost effective. So that's a little bit of a different add. And then the picture below that is actually what sometimes we're used to seeing when we get utility rates from our DPW or our installations. And so I just kind of wanted to point out some of the prices to y'all of, you look at this bill and you see that it's $4.45 for 1,000 gallons. And just seeing what kind of price that is, this is maybe high for some, probably low. I believe this came from Fort Hood, if I remember correctly. But just kind of show what kind of rates we're charging for these utilities. So we can see that, with, most people, have owned a home or something similar, that they know that when you get billed, usually you're billed with your water and your sewage combined to make for a utility rate. And so just kind of an interesting kind of food for thought here is it's, $4.45 for 1,000 gallons of potable water. If you were using a low flow toilet, which is 1.28 gallons per flush, that means you could flush that toilet 781 times for less than $5. And so kind of a little funny consideration, I did this kind of for the class that we taught, is if you actually use 9 individual squares of toilet paper with each of those 781 flushes, your cost for the toilet paper would equal your cost for your water. So 9 individual squares per flush. And that was actually pre-COVID when you could find toilet paper. Who knows what it is now, if you can find it, kind of thing. Hopefully the market's back up. But so anyways, just kind of wanted to show, how, at the end of the day, water is actually reasonably cheap. It's actually a reasonably cheap utility for how vital it is. It's kind of, surprising, but it is essential. It's a good thing that it's low cost and freely available. However, that can play against us when we try to do life cycle cost analysis, as well as trying to stem people to conserve. Okay, so we're going to jump into the indoor water. So this is where we have some highlights from the UFC. So we have some highlights from the UFC referring back to the International Green Construction Code. From that, we can see the UFC is calling out that Green Construction Code for building water use reduction. It also has requirements for EPA WaterSense labeled products, and that we're going to meet the requirements for special water features. So the section below here in red, those are the ones that we're actually going to pick up in this presentation. Went ahead and cut out the commercial food and medical laboratory, since those aren't real common, real typical. Just kind of keep it high level for the presentation. So okay, jumping into the indoor water from the former ASHRAE 189. So the easy way to do conservation is to use less low flow fixtures. A lot of people are familiar with the table here. This comes out of ASHRAE 189. This has been around for quite a while. These flow rates. There's definitely more water conserving features out there than these flow rates, but these tend to be a good, kind of general starting point. They're greater than the baseline. However, they're not typically excessive. Went ahead and put in the exception that if you're using an existing plumbing infrastructure, you're allowed to have 1.6 gallon per flush, and that's really to make sure that you don't have blockage issues later on after you're done with your renovation. If you haven't been to this table in the 189 or IGCC, this is a good starting point for if you're looking at your plumbing fixtures. If you're writing your specs, things like that, it's good, just common knowledge to know where that is at. So jumping into continuing that, so the UFC actually says that bottle filling stations are the requirement is optional. So if you look in I'm going to keep kind of accidentally referring to it as ASHRAE 189, but the IGCC actually calls for bottle filling stations on 50% of the drinking fountains that are inside. The UFC then says that is optional, and then however the STD policy requires the bottle filling station. So kind of required, optional, required, kind of just depends on your flavor and what organization you're working that through. But the bottle filling is a good idea. A lot of people are using reusable bottles. Great all-around solution there. Went ahead and highlighted that there's an exception on using low-flow fixtures or WaterSense labeling fixtures if you're sanitizing biohazards. Seems like a good idea. And then there's actually a link to the EPA WaterSense website on here as well. And so the EPA WaterSense products, if you're wondering kind of what that is, that's a product that's certified to use 20% less water than regular bottles. So if you see that, you're shopping at Home Depot or whatever, you can look for that and know that that's a more water conscious product. Okay, so next on the indoor water, the IGCC has some statements on appliances. Didn't want to do a real deep dive on that. It talks about clothes washers and dishwashers. It refers to the products being Energy Star, and there's some maximum water factors. Didn't want to get too deep in that. Just know that if you're buying appliances, you'd be looking for the Energy Star, similar to how if you're buying fixtures, you were looking for the WaterSense label. Okay, jumping into my favorite part is mechanical, is the HVAC systems here. So the IGCC has requirements on your HVAC system, and some pretty good, somewhat simple solutions to save water. First one is no once-through cooling systems. Real simple example is if you've ever seen the misters attached to the fans, at a football game or something like that. Not a real efficient use of water. Can make things cooler, but you're not really getting a whole lot of reuse out of that. And then it says potable water with that, and hopefully no one's using reclaimed water or less treated sewer water and spraying it. So hopefully we're using potable and we're being intelligent with that. Next one is minimum cycles of concentration for cooling towers. So in simple terms, this is the number of times your cooling tower recirculates the water before it backwashes it. The criteria has different settings based on your makeup water hardness, and the number of cycles ranges from 3.5 to 5 depending on your makeup water. Personally, I've seen a lot of poor examples of this. I've come across multiple cooling towers that are doing one cycle of concentration, and you go through a lot of water and you go through a lot of chemicals, and so that's one of those. It can make life a lot better if you have things set up correctly. So that's a real simple operations item, is checking your cycles concentration. And then the last one is cooling towers and evaporator coolers equipped with makeup water meters, blowdown meters, connectivity controllers, overflow alarms, and the cooling towers will have drift eliminators. So there's threshold with all these items. I put the table here with the thresholds for those of y'all that kind of run into that. And really it's kind of, it's extra items that you need to have, but they're things to help you know how your system's operating and determine if they can be tools to help determine if you have issues later. And the cooling tower drift eliminators are kind of an extra option that you can get from your equipment manufacturer. They're not a rocket science feature. They're just good at keeping the water from leaving the fill and can help keep water in your tower. So nothing too drastic with those. So jumping into the next one here. So the IGCC has a requirement for condensate harvesting. And so the map down here, I kind of drew, this is not the actual units that they're talking about up here at the 1% design condition, but it is an average annual wet bulb map. And so from the IGCC, it says you're going to do condensate harvesting on units that are over 65 MBH, so a little over 5 tons. You're gonna capture the condensate and reuse it. So more or less, looking at this map, if you're on the right side of the U.S., you would probably maybe fall into that realm. And so I kind of put the Fort Worth weather data here, showing that we would be above that 78 threshold that goes into that realm. So this was interesting. So I'll give you all kind of my interpretation on this, because you don't see a lot of condensate harvesting in action. Is we will get into the alternative water later on, and we will see a statement where it talks about alternative water is to be applied if life cycle cost effective. And so I think that's where probably a lot of this goes, is you have a statement in the IGCC that says you're going to do this, but then we also have a statement later on that says when you're doing, this condensate harvesting, if that's an alternative water, are you then life cycle cost effective? And so there's some benefits to condensate harvesting. ASHRAE or IGCC didn't add that arbitrarily. If you can capture that water, that's coming off of your coils, you can take that load off your sanitary sewer system and you can reuse it. There's some challenges with it as well, though, is, this water is not pressurized. So you want to move it other than gravity, and you've got to pay with a pump, and that costs you money. As well as this water can have a high amount of total dissolved solids. It can also have some metals content. You can have steel from the fins and copper, and so it can have a higher, I'm going to call it toxicity, but it can have properties that aren't great. You don't want to be drinking it right out of the tap from that. So the economics with harvesting it can a little bit be an uphill climb if you're trying to make it work by itself. If you go back and you think about our previous slide, where we can get 1,000 gallons of potable water for $5, how long and how much water am I going to have to collect off my coil to be able to make that up? Like most sustainability things, if you're looking at it in a vacuum, it's going to be really hard. However, if you pair it up with other disciplines, like your site has a need for a water cistern for LID, capturing that condensate and routing it to an already existing storage tank will help your economics with that. So jumping into roofs. This is another one that maybe other parts of the country deal with a little bit more. Personally, I haven't had to deal with it very much, but it talks about the IGCC talks about what you can use water for when you're with your roof. So the first one prohibits you from running a hose up on your roof and spraying water trying to evaporatively cool your roof. It says you're not allowed to thermally condition your roof with water, potable or reclaimed. And that's kind of like the once through cooling with that. And then interestingly is in-ground irrigation systems on vegetated roofs using potable water and off-site treated reclaimed water are prohibited. So I think if you had an on-site reclaimed water that you were treating, you could use it for that. And then potable water and reclaimed water for irrigation after the vegetation establishment period is prohibited. So they really don't want you putting sprinklers up on your green roof, I guess. They'd rather you, I guess, choose a correct planting rather than really trying to run that or using your on-site treated. So if you were capturing your condensate in a cistern or things like that, using that maybe rather than getting potable water or reclaimed water from a sewer treatment plant or somewhere like that. Okay, so next we're going to kind of touch on what LEED has to say about the indoor water use reduction. So the intent's pretty simple, reduce the indoor water consumption. That is a pretty simple statement. And so then we can kind of see the requirement. We're going to try to reduce it by 20%. We're going to see a similar requirement here that we're going to use WaterSense labeled products and Energy Star labeled products. So we can see where we're lining up with the UFC with some of that criteria. And then we can see an example of the credits that you would get. So 25% savings is going to get you 1 credit, and then you're going to get 5% intervals to 50% where you get 6 credits. And so example of a project we did with multiple barracks and showing the baseline versus the design with the LEED calculator. This is kind of an old one. One good thing is if you're using alternative water is it can contribute to this, and you can actually get exemplary performance credits with this water one, and so you can actually you can pile on some of your credit savings if you're using alternative water and using low flow fixtures. So there's a lot of potential you can get up there. So you can get up into that 6 credit range, which if any of y'all have done LEED, especially on the mechanical side, you know that 6 credits is quite a bit. That's over 10% of what you need. So for silver, so it's not to be taken lightly if you can do water conservation. Okay, so jumping into metering. So I went ahead and lumped indoor and outdoor metering into one. They had pretty similar statements. So just so you all know here, the policy is kind of written around each individually. So the highlights from the UFC are that we're going to install advanced water meters to monitor the building indoor potable water consumption. That would also, probably be tailored to say, the outdoor water consumption as well. And so then we see with this that there's a DoD meter policy. I went ahead and put the link on the slide here. I believe it's from 2013, so it's a little older. And then your meters are going to be configured to meet the cybersecurity, so that's a good thing. Let's not make a shortcut for someone to get in and hack the system through the smart meter. So apply your cybersecurity controls through that UFC. And then we can see here that, with the, you can see here with this that we're going to be metering potable and non-potable water per the ASA guidance. So I think I saw the question pop up of what is a smart meter. So that'd be like a digital meter, one that you could actually log and trend the data from. If you kind of think about more or less, probably a lot of installations are actually going towards it where you get smart meters. The old school was the rotary dial that just kind of spun. You can kind of think about this being your electric meter nowadays. It's kind of tracking along that similar, where you can actually go in and pull the hourly or smaller interval data of the usage. So that's going to be what the smart meter is. It's going to be wired up to the network in some way, shape, or form that's compliant, and that. So, and there's some provisions in the metering policy that talk about what to do if you don't have a network and things like that. So I'd say look at the meter policy and kind of see, and then. But yes, it is going to be a smart meter that has the ability to run some logs and trends. Okay, so then we'll jump into the lead on that. So that's kind of, you'll see this kind of segue of we'll talk it and then we'll talk the lead. I don't know if I gave a great segue into that before, but the Army uses a lead for the third-party certification. So that's why we're mentioning this. Is a lot of times the lead is where the rubber meets the road for your third-party certification. So the intent is to support water management, identify opportunities for water savings by tracking the water consumption. So that's why you need a smart meter, because you're probably not going to have someone go out there with a clipboard and read the rotary intervals. You certainly could do that, but it's a lot easier if you have a smart meter that can capture that data. So the requirement with this is you're going to install a permanent meter. LEAD has a statement about committing to share the data with USGBC. DoD has a waiver that doesn't let us do that. So just so you know, and I'm sure Eric and some of the others can definitely get you up to speed on some of that. And a lot of that is for security, so that way people aren't trying to track troop movements through the meter data of looking at where the water is. And then you get into your credits. And so installing 2 or more meters on the following subsystems, and they're pretty simple subsystems. With this, I've had some people kind of push back on me for doing some of this, because some of these are things that you wouldn't typically meter, like you wouldn't typically meter domestic hot water, or indoor plumbing fixtures, or some of those other items. But as far as cost to benefit for getting a LEAD credit versus some of the other alternatives or avenues that you can go, metering tends to be a pretty low cost. It's low on the sustainability tree of fruit that I try to pull off. It provides a tangible benefit to your O&M staff if they can use it for leak detection, as well as you're complying with the Army policy, and then also you're able to get your LEAD point with that. So it's kind of a win-win-win with that scenario. Had people say that, why would you meter reclaimed water, especially if it's a utility that you're getting at little no cost or it's free or anything. I think that it's a great thing, because it's kind of like the bottle counter on the bottle filler on your drinking fountain, where you can say, look, we offset this many gallons of potable water with reclaimed water. So I've had someone kind of push back on me with the reclaimed water meter, but I think as far as telling a good story for your inner water conservation, that's a good one. So now we'll jump into outdoor water. So we kind of talked indoor, pretty high level. So now we're going to talk outdoor. Per the stats, we use a lot of outdoor water. Irrigation is a big one. I'm sure, living in Texas, I know it. The first thing to go when we start running low on water is stop watering your yard every day, and things like that. Of conscious irrigation can be a big factor and can save a lot of water. So UFC prohibits potable water for irrigating new landscape and other plant establishments. It has a statement in here about existing systems with a single meter that you're going to reduce the combined indoor and outdoor water use by 20% compared to 2007. And then you're going to show preference for contractors who are certified through a WaterSense label program or recognized credentialing program. And then you're going to meet the requirements of UFC 201-2 landscape architecture for additional requirements. So then jumping into LEAD with that. So pretty common sense way to save outdoor water is to reduce the consumption. And so the LEAD gives you two kind of paths that you can go is you can either not provide irrigation or you can provide reduced irrigation. The reduced landscape water requirement is by at least 30% from a baseline that you would use their tool to calculate through. So pretty straightforward. You know, if you go option one for the credits, there's 2 credits available. You show that the landscape does not require permanent irrigation beyond a 2-year period after you've established it. And then option 2 with the reduced irrigation, you're reducing your water requirement by at least 50%. So 50% gets you 1 credit, and then if you go all the way to 100%, you get 2 credits with that one, and you're using the EPA's WaterSense budget tool. So now we're going to jump into alternative water, and this is kind of a newer one, not as common, or maybe it is for some people. I haven't seen a whole lot of it within USACE, with the exception of the golf course. I think a lot of people are used to the purple sprinkler heads on the golf course, but probably not as much within their buildings. There are some cool ones that have used it, but wanted to start the conversation with alternative water by kind of telling y'all what the definitions are, because some people you hear alternative water and you kind of don't really know what you're going with. So start with potable water. You know, it's water free of impurities. You know, in the amount that won't cause, you know, harm or psychological effects. That's good. You know, there's no bacterial chemical qualities with it, you know, or it's meeting those. So you more or less, you know, this is the water coming out of your tap. You know, hopefully the water department's doing this well, and this is a true statement that you're getting potable water. Y'all might be wondering what this picture is. This picture is actually a field installation. They were adding a building onto a well pump, and they needed temporary water while they were making the connection. Well, the semi pulls up and it's got these tanks of water, and this is their backup water. And it was definitely probably, you know, they may have filled it up with potable water, but who knows what was in there before. And it was not the way you really want to see things going. Of, you know, you're going to drink water out of the black tubs in the back of this tank where nothing's listed as potable on the sides. Made me a little nervous. So that's what's going on there. Yeah, you know, like I said, I do some backpacking, and I filter my water before I drink it, and I think that's a good standard practice of, you know, watching what you're drinking. So here we'll jump into the actual alternative water. And so what are we talking about when we talk about alternative water? So is it non-potable water that is not safe for drinking, personal or culinary usage, alternate on-site non-potable water. And so all these definitions are coming from the International Plumbing Code. If y'all are wondering, where are these definitions coming from? This is all in the IPC. So non-potable water is water from other public utilities. It's an on-site surface source, subsurface, natural freshwater sources. Examples are water from a gray water, so like if you diverted your sink, on-site reclaimed water, so like your rain gutter, or I guess reclaimed water would be like your condensate, and then collected rainwater, collected condensate, water rejected by reverse osmosis system. So this is water that you can get that, you know, it hopefully won't have solids in it. You know, that's kind of a little bit of a high level thing there, but, you know, it's reasonably-ish clean, you know, that you're still going to probably want to treat it before you actually do something with it. And then gray water. So waste discharged from lavatories, bathrooms, showers, clothes washers, and laundry trays. And so here in the picture here, we had a project where we actually used site provided, so there was a utility that provided non-potable water. It was a relatively high classification level, and so it was fairly clean. So we actually ended up going that route with toilet flushing. And so for doing that, we had to put these signs in the bathroom that were telling people not to drink the water from the toilet. And that was kind of comical of, do we really have to have a sign that tells people not to drink water from the toilet, but to be code compliant, we put that in there. So now we'll actually jump into what the UFC says about alternative water. So here we kind of pick up where what I mentioned before of, I like that, Billy, where life cycle cost effective, and this is also permitted by state and local laws and regulations. So, this is where, the states and local municipalities may have differing opinions of what different water sources are and how they're classified. So where life cycle cost effective, and, use alternative water for non-potable applications. So, your toilet flushing, your lawn irrigation, those kind of things, so that's, yeah. And so I guess just to talk briefly on this. So, as far as water goes, and y'all probably heard me say it multiple times now, but water is a relatively cheap utility. And so you can, to base your use of alternative water on cost with economic cost analysis, it's going to be a little bit hard to get it to pay for. Had a project, and they actually told me that the water that we were going to get was actually going to be free. The alternative water was going to be free. It's going to be pressurized. And even just the minimal valves and fittings that we had to get to be able to get that water into the building, if they started to charge a rate for it, anything over 50%, it was going to not be cost effective. And that was without us pumping it. That was without O&M. That was without a lot of things. Is the alternative water, if they ever decided to charge for it, was going to need to be half the cost of the potable water for it to even be cost effective. And I think that was at a 25 or maybe even a 40-year study. And so it can get pretty thin when you can get $1,000 of potable water for $5. That's a hard one to sell economically with a cost analysis. Not that it shouldn't be done, but it's just that's the realm that we live in with the statements the way they're written. I think maybe as we go more towards resiliency, we'll see some applications where maybe we take a loss on the economics because it would provide an additional resiliency. But we'll see kind of what happens with the criteria. So just kind of simple one to kind of overview. So this is talking about the different classifications. So here you can kind of see some of what's going on is you have different classifications based on different states. You have what states allow you to do with what. And so the one that I was dealing with on my project was actually a class 2, and so we were allowed to do toilet flushing. But you go up here to Texas and you look at, and you cannot do toilet flushing with that class 2. And so it's going to vary probably widely by where you're at in your municipality. So, what some of your regulations are. And so just keep that in mind as you're evaluating alternative water. Just so you'll know, 1 is the cleanest and then goes down to 5, which is where this is where you get pretty bad. The one that we were dealing with was a side stream off of a sewer treatment plant, so it was treated water that was not fully treated to potable standards. And so that was kind of where we came from with ours.
Hey, Kirk, where can somebody find that chart?
Good question. So I had down my resources were AWWA, and it was manual M24, and it was called Planning for Distribution of Reclaimed Water. And so that was one of the resources that I used. And then these charts right here actually came from, one is from the state of Texas, environmental quality, and the other one is from the state of Oklahoma, environmental quality. So I'll put the slides up there, and the notes have this stuff in there. The AWWA manual is good for kind of all around planning. And then as far as your environmental rules, a lot of that was actually just research.
So folks should probably check state by state as their projects come up.
Exactly. Yep. So just jumping into, this is probably a little bit redundant, but, what are some of your common sources of non-potable water? If you have a side stream process off of a sewer treatment plant, rainwater, condensate, gray water, or, like your sinks or something else that's a side stream, real high level picture of just, collecting water off a gutter, putting it in a cistern, being able to pump that out, things like that. You can see, per your LCCA, buying this equipment, you start racking up a first cost on that system, with these processes. That's what can make some of your economics challenging to overcome, is some of those. I'll say probably the easiest to implement, if you can get it, is, this off of a sewer treatment plant. But, there's always some great resources. And really, if your user or someone has a lot of interest in it, you can plan accordingly. There's a lot of regions where, water is a very precious commodity. And I think we're seeing that more and more as things progress. So with water, kind of want to just mention backflow prevention. It's a big part, as we're protecting and conserving water. So the first part is protecting, and so we don't want to connect up an alternative water source and have a cross contamination that then goes and contaminates our potable water source. So the different levels of backflow prevention, you have an air gap, you have a reduced pressure backflow preventer, and then you have means to limit cross connections. This photo down here is actually from that AWWA manual, and what it's showing you is actually where you would you have a potable source and a non-potable source, and you would actually physically remove the elbow and make the connection, so that way you don't have a cross contamination, and they have a cross contamination plan with it, so that way you don't get someone in there that just opens a valve and the next thing you know, you've contaminated your building's water source. So there's a lot of good resources out there, but it is a conscious design effort, to do some of that. And so then going into life cycle cost analysis a little bit here with this. So just kind of wanted to give a picture of what like a package treatment skid could look like. This is one that we considered, and you can get some of these treatment systems packaged from a vendor, which is a great resource. However, just kind of to go along with what we said, is there's some considerations with it. Of are your O&M personnel going to be able to handle this? And then as well as the economics of, is your water savings going to be able to capture all of this, material being purchased and still be cost effective? And I think I've kind of brought that up a couple times. There's also some links to, this is a rainwater harvesting system. Another thing that you might come across is some municipalities might require dyeing and specific levels of treatment of the water that you capture. And so that's another thing that might kind of come in there, is if you actually have to dye it versus just putting signs that say, here's non-potable water, but if you actually have to have some kind of dye, so that way it's visible if there's a cross-contamination or a leak. Okay, so now we're going to jump into briefly just touch on stormwater management. So the UFC, real easy, it just says refer to the UFC 3210-10 low impact development. So that's easy. But yeah, so it's low impact development is stormwater management strategy designed to maintain the site hydrology to mitigate adverse impacts of stormwater runoff and non-point source pollution. So LID actively manages the stormwater runoff by mimicking the site's pre-development hydrology using design techniques that infiltrate, store, evaporate, to close to its source of origin. In short, LID seeks to manage the rain beginning at the point where it falls. And I think, this has been around for quite a while. A lot of people, especially civil, are very familiar with this and the criteria. So the applicability of this UFC, you can see that with this, if you have, both of these conditions, that your construction's expansion of one or more buildings, and then as well as your footprint and things that go along with that. So keep it pretty high level on this UFC. There's a lot of information in the UFC. Just kind of wanted to point out one of the kind of cool graphics on this, from that UFC were some of the flow charts. And then you can see some of the on-site design options, and that you can have bioretention areas, permeable pavements, cisterns or recycling, and then green roofs. And this is one of those, especially if you're doing some of these, cisterns and green roofs, if you can get your HVAC condensate harvesting in there, if you can get some of your alternative waters in there, how you can actually kind of stack these up, and similar to like the whole building, LCCA is looking at the systems, outside of just the individual, but looking at the benefit that these can play to the system, then it may help the economics with some of these, especially if you are pushed into an area where you're already providing a cistern or something like that. Then if you're doing that to meet other code requirements, then you have that ability to add on those others without possibly hurting your economics.
Hey, Kirk.
Yes.
Tim Peasy was asking if anybody's done a green roof project and had DPW or the base civil engineer support that. I don't know if you've had a case where they've done that, or if anybody else wants to jump on and just mention that.
I haven't personally come across one that I could talk to. The closest to a green roof I have is when my trees drop their leaves and my gutters no longer work. So.
Well, if anybody else has come across that, then just add that to the chat box or email Mr. Peasley, please.
Okay. Well, just to kind of sum up, some of the things that we talked through here were, our overall goal is protect and conserve water. We're doing that through water conservation indoors as well as outdoors. We're using metering to try to have a potential for, capturing leak detection as well as, logging and trending our usage. We have landscaping requirements. And then we briefly talked on, what is alternative water and what are some stormwater management strategies. So I'll open it up to questions here. Got through the content reasonably quick, so we can take some questions if there were any.
I don't see any more questions in the chat box. If anybody wants to jump on the line and ask a question, feel free. Kirk, you must have covered that material exceptionally well.
There you go. Yeah. So yeah, if y'all have any questions, my contact info is there. And I'm happy to do that. I'll say I usually live in the building realm, so if you get something too civil or dirt work related, I'm going to have to punt. But I'm happy to field some questions with that, and then looking forward to some of the upcoming webinars, the LCCA and the energy.
Hey, Eric, I don't understand anything you just chatted there. What does that say?
Oh, there's plants called sedums. They're basically I don't know, kind of like little cactuses or something that they retain water really well, and you can plant them on green roofs, and they don't need a lot of irrigation because up on a roof it's kind of hard to maintain the moisture, and also you can get these little granules that you can mix into the soil mix, and that they basically absorb water, turn into a gel, in the rain, and then they kind of slowly release the water as the soil around them dries out, and so that kind of helps temper the moisture swings. So that's probably your best bet for success with the green roof.
Hi, it's Annette. I pasted in links to the Salesforce Tower, which is the largest black water recycling system. Has the Army ever looked at black water recycling? Or should we, if we have a big barracks in a drought area or something like that?
I looked at
The
some
links.
for black water reuse for forward operation bases for a research project, but it didn't get funded.
I think forgot his name. I think Searle's actually working on that at Cibatech. We've got one of those. Or maybe it's just recycling the laundry water. But that's a good example if you want to click on that.
I don't know exactly what you're calling Blackwater, but a lot of the lake projects have aeration systems. So that's
Well, they're
pretty
they're
common.
collecting water from the toilets and they're treating it and reusing it in the building. That's what I'm calling black water.
Yeah,
Something we've never gotten to. Nobody's touched yet. But there's a huge example project, the Salesforce Tower. It's quite interesting. So the commercial buildings are starting to do this in big, large scale water restricted areas.
it's a tough bar to clear for health departments to accept, because the possibility of nasty things in toilet water getting into getting airborne through irrigation or anything like that. So there's a lot of limitations, but you have to find a friendly health department or whatever jurisdiction they have.
Our common construction types, you saw the economics Kirk presented. I mean, we can't even justify simpler systems and building level systems. So trying to justify sewage plants for our typical construction would be tough. So it'd have to be something exceptional, like you mentioned, large complexes in the middle of nowhere with no infrastructure.
Or like forward operating bases where you have to truck in all the water you use.
Yeah, they could just use composting toilets.
Mhm.
So Mark Kodak and Elizabeth Janacek, who are both gone now, were working on something they called the true cost of water that would give you a higher water price for your life cycle cost estimates, because if water's not available, you shouldn't be using a really low cost value for water in your calculations. I don't know how far that got because they're both gone, but that would be a good way to help make these projects more life cycle cost effective if we could find out what the true cost of water is, whatever that is. Over.
Like if you don't have a utility service, you have to truck water in. That's comparison or something like that.
I got examples of projects where there's just not that much water available, but the utility rate was really low. That's just not realistic.
Well, it's realistic because that's what they're charging, and somehow they're getting water to people. So.
Yes, I agree with that. Yes, you tend to see that it's a relatively cost-effective utility. But yes, if you were using your LCCA, if you used an alternative, an example I've seen of something kind of like that is people using the price of photovoltaics as their electric utility rate to help, their economics of, if you had a project that required, net zero or some other kind of phrasing like that, is using that to sway your economics versus, what you're going to get specifically off the grid. So kind of the same mentality of if you use a higher utility rate, you're going to be able to have things paid better.
Does anybody know where the net zero water pilot plants stand now? Are they still trying to do that, or?
There was a
Up or-
IE&E website had a net zero section where they're kind of tracking that stuff. I haven't looked to see when the last update to it was after Ms. Hammock left.
I think we're talking resilience now.
Yeah.
It's a new word. It's the same kind of idea.
Yeah, same thing, different buzzword.
Sorry, I used the wrong word. I'm guilty of doing that a lot.
It's all right.
Just like S3 189 is it's hard to change once you get used to it.
Yeah. Yeah, now it's the IGCC. And different numbers for everything.
Okay. Well, I think we're good if we want to go ahead and like I said, my contact information's out there. If anyone chooses to reach out to me, and eventually I'll get these slides up here on the sustainability site, and just feel free to reach out. And I appreciate y'all calling in today.
Thanks, Kirk.
Thank you.
Everybody.
Thanks, Kirk.